Alrighty, today we are going to be talking about limits numerically, graphically, and then algebraically whenever we have time. But first, we got to talk about the definition of a limit. Essentially, once f of x becomes arbitrarily close to a single number, L, so we're going to call that L, and as x approaches that limit from either side, the limit of f of x as x approaches c is L, and here's our little lovely notation that we're going to be using. So the limit as x approaches c of f of x will approach L, or is L. So we're going to look at sine x over x and 1 minus cosine of x over x numerically using a table of values, and then we're going to see how that relates to our graph. So on Desmos here, I have sine x over x, and I have my table of values from negative 0.1, negative 0.01, negative 0.001, 0, 0.001, 0.01, and 0.1. And as you guys can see from my table of values here, that at 0, I'm undefined, because at sine of 0, I'm 0, and then at x, that's going to be 0. So I have 0 over 0, which is going to be undefined. But if you were to look at my table right here, you could see that between negative 0.001 and 0.001, it's getting closer and closer and closer and closer to, let's say, 1, because I have 0.99999, 0.9999 right here. And as you can see here from my graph, if I were to zoom in a little bit, as it get closer and closer and closer, even though at 0 it's undefined, I could say that my limit as x approaches 0 for sine of x over x will be approaching 1. Likewise, I could do the same thing for the other one. Let's see, that one is the 1 minus cosine x over x. So 1 minus cosine of x over x of x over x. And if I were to do the same thing here, as get closer and closer and closer and closer and closer, even though 1 minus cosine of x is 0 and x is 0, aka 0 over 0, aka I get an undefined number, as I get closer and closer and closer, my limit as x approaches 0 of this function right here is going to be 0. Now, these two functions right here are going to be very important whenever we start doing trig limits in the next video. So here, I know that the limit as x approaches 0 of sine x over x will give me 1. And here, this is going to give me 0. Now, graphically, we're going to be doing the same thing, just looking at the graph and seeing how it approaches from the left side, the right side, and from either side. Remember that here, this means that we are approaching negative 3 from either side, so from the left and the right. Meaning that if I have a two-sided limit like this, I want to make sure that my left-sided limit and my right-sided limit will approach the same numbers. So here, if I were to think about f of negative 3, that's just my defined value at negative 3, aka 1. Now here, we have the limit as x approaches negative 3 from the left. So this negative sign means that I'm approaching the value from the left side. So if I were to look at negative 3 here, you'll notice that from the left side, aka from this side right here, I'm approaching it from the left side, which is going to give me negative 2. Likewise, for this one here, I'm approaching negative 3 from the right. So instead of the left side right here, I'm approaching it from the right side. So from the right side, I'm also approaching negative 2. So based off that, I know that the limit as x approaches negative 3 is also going to be negative 2. Even though my function value at -3 is 1, my limit, though, however, is at -2, because I'm approaching -2 from the left side and from the right side, right here. However, this is going to be a good introduction to continuity whenever we talk about continuity in a couple of days. We can do the same thing for f of 2. So f of 2 is going to give me 3 right here. And as x approaches 2 from the left, I could say that it's going to be 2. Now, as I approach 2 from the right, I have a problem because I don't have anything from the right side. Because I don't have anything from the right side, I could say that this does not exist. D&E does not exist. Meaning that my limit as x approaches 2 from the left to the right side does not exist. Same thing with f of 3. So here, I know that my value is -1. Now, as I approach 3 from the left, though, notice how I don't have anything on the left side. Because I don't have anything on the left, my limit doesn't exist from 3 to the left. But 3 to the right, as I approach from the right side, it is going to approach 3. And then because my left side limit and my right side limit does not match, my limit does not exist for x approaching 3 of f of x. f of 5 here, notice how I don't have a defined value at f of 5. So at f of 5, we are undefined. Now, as I approach 5 from the left, it's going to be -3. As I approach 5 from the right, it's going to be +1. And because my limits are not the same, aka they don't match, my limit does not exist. We'll also talk about this right here in terms of continuity and how this right here is a little jump. All right. Now, whenever we are taking limits algebraically, what we want to do first is do direct substitution, aka just plug and chug and see if it works. That's always what you want to do first because that's going to be the easiest method, plugging and chugging. So here, as the limit, as x approaches 3, the square root of x plus 1 over x minus 4, I'm just going to plug in 3 and see what happens. So if I plug in 3, I get the square root of 4 over -1, which is the same thing as 2 over -1 or -2. And that was just me plugging and chugging. Great. Perfect. Now, for this one right here, the limit as x approaches -1 of x cubed plus 1 over x plus 1, I'm going to do direct substitution. So I'm going to do -1 cubed plus 1. That's going to be 0. And then -1 plus 1, that's going to be 0. So now I have 0 over 0. Now, because I have 0 over 0, this is called an indeterminate form. If we have an indeterminate form on the AP exam, however, you do want to make sure that your notation is correct. So whenever you're working things out with indeterminate form, what I want you guys to do is make sure that you have your limit of the numerator and your limit of the denominator and say that this is an indeterminate form. Indeterminate form of 0 over 0. Now, even though I have 0 over 0, my limit isn't 0. What we're going to do is think about strategies in terms of how can we probably, factor this right here to see, maybe I could cancel some things out. Now, thinking about your Math 3/pre-calc skills, hopefully, we know that we can factor x cubed plus 1. Whenever you are when doing these types of problems, you do want to make sure that you keep your limit in terms of simplifying. So I have the limit as x approaches 1 of x plus 1 of x squared minus x plus 1, aka SOAP. So if you forgot SOAP, aka if you forgot how to factor your cubic functions, go ahead and review that. So I have that. Now you could cancel out the x plus 1, which means I have the limit as x approaches 1 of x squared minus x plus 1. And now I could use direct substitution. So I could say 1 squared minus 1 plus 1. So that, oops, that's -1. Sorry, let me do that again. -1, -1. So I get 1 plus 1 plus 1, which gives me a limit of 3. Notice how I drop the limit whenever I am plugging something in. So you always want to keep the limit and carry the limit if you have a variable around. You could drop it whenever you're substituting in on the x value, in this case -1 into x. Same thing here. I have x minus 3 over x squared minus 4x plus 3. And I want to see what happens when x approaches 3. You'll probably notice that, my numerator is going to give me 0. And my denominator is also going to give me 0. So this is an indeterminate form of 0 over 0. So now we just got to think, what can I do to simplify this? Well, I could factor the bottom to get x minus 3 and x minus 1. Cancel that out. So now I'm left with the limit as x approaches 3 of 1 over x minus 1. And then if I were to use direct substitution, I'm going to get 1 over 3 minus 1, or 1/2. Same thing for number 4 here. So the limit as x approaches 5 of 5 minus x squared is going to give me 0. The limit as x approaches 5 of x minus 5 is also 0. So this is an indeterminate form of 0 over 0. Yes, you do actually have to write all of this out, just like I did here and here, so that you earn all of your full points on the test and on the FRQ in the AP exam. So now I just gotta think, how can I simplify this? Well, I have the limit as x approaches 5 of 5 minus x, 5 minus x, and then what I can do here is take out a negative, factor out a negative right here. So if I take out a negative, I'm going to get negative x plus 5, which I can flip around to be 5 minus x. That gets canceled out. So now I have the limit as x approaches 5 of negative 5 minus x. Substitute in 5. 5 minus 5 is 0. So this tells me that my limit is 0. Now right here, this is okay to have 0 as an answer because this isn't an indeterminate form. This is just me direct substituting and getting an answer of 0, not 0 over 0. So there is a difference between 0 here and 0 over 0 here. All right, in the next video, we'll talk about more complicated limits. Well, they're not really complicated, but more limit strategies. And then we'll talk about piecewise functions and all of that good stuff.